All right, so if you convert degrees to radians, you're going to multiply by what? Pi over 180. Your degrees cancel and your zeros cancel. So that gives you negative 21 pi over 18. And then that reduces, they'll both divide by what? 3. So negative 7 pi over 6. Did that one go? Yep. It went? Okay. Same thing for this one, but backwards. You're going to take your 5 pi over 4 and multiply by 180 over pi so that the pi's cancel. You almost can't mess it up because the degrees should cancel or the pi's should cancel. And if they don't, then you have it backwards, right? So here's the way I do this. I keep the 5. And again, you can do whatever suits you, but I like to keep the numbers smaller. So I keep the 5 and I would do 180 divided by 4. Because if you divide first, it'll keep the number smaller. If you do 5 times 180, you're going to get a really big number. So that's why I don't do that. So 180 divided by 4 is going to be 45. And then if you multiply those, 225 degrees. Did that one go? Well, okay. I'm going to pause this. I want you to try the ones on the back, and then we'll go over those. All right, so here we'll go over number 4 together. So 7 pi over 6. All I need is which quadrant it's in, and there's only 4. So if you lose your mind, you got a 1 in 4 chance of guessing. And I need what direction you went. Let me get out my paper clip. Just watch. 1, 6, 2, 6. Straight up would be 3, 6. 4, 6, 5, 6. Do you see how 6, 6 is one whole pi? Okay, good. Head's nodding. So 7, 6 is just slightly past that. So quadrant 3, and it should look like that. What's that? That's all you have to do for drawing it. Now for the coterminal angles, you're going to add a rotation or subtract a rotation. Coterminal means you landed in the same spot, but you went around different amounts. It's like you and your friend are out on the track and you run around once and they run around 10 times, but you both ended at the same place, but you went different amounts of rotation. So what is one whole way around in radians? It's 2 pi, but good. I need for that to be 6. Bless you. So it's 12, 6. So we're going to do 12 pi over 6 plus 7 pi over 6. We're adding another rotation. That's like you went around once more. So just add those together, and that would be what? Yeah, 19 pi over 6. So that's your positive one. Negative is like you go that way, I'll go this way, and we're going to meet on the other side. So you're going to take your 2 pi, which in this case we're writing it as 12, 6, and you're going to subtract 7, 6. Just put a negative in front of your answer to indicate that you went backwards. But for one of them you add, and for one of them you subtract. That's it. So this would be negative, good, 5 pi over 6. When you go back and do number 3, you're going to do the exact same thing, except since it's in degrees, instead of 2 pi, what's a whole way around? Is 360. Good. So you're going to draw it and then do one adding and one subtracting, but use 360 degrees. All right. So what quadrant is 120 in? Second. Okay. So it's going to look like this. And to get your positive coterminal one, you're going to add a rotation. What did you guys get for the positive one? All right. 480 is correct. And then you're going to do the same thing, but subtract and just put a negative in front of your answer to indicate that you went backwards. Again, this is like you go that way, I'll go this way. We'll meet on the other side. So that should be negative 240. Perfect. All right, reference angles. Negative 210. You're going backwards. Where's my paper clip? So look at, you start here and you start rotating down. So we're going to go backwards 210. What quadrant? Don't talk over me. What quadrant is that going to land you in? Yes. Quadrant 2. Good job. Now your reference angle is just how far it takes you to get back to the x-axis, back to the horizon. So if this is 210, negative because we went backwards, but it's still 210, and the flat line is 180, what's left for this amount right here? 30 is your reference angle. Good job. 7/4. What quadrant? And I don't always say pi, okay? It is the 4th quadrant because 8/4 is 2 pi. That would be the whole way around. I always like the ones that land in the fourth quadrant because it looks like Pac-Man. All right, your reference angle is this amount. That's the amount that the Pac-Man is eating, kind of. And that would just be pi over 4. Whenever it's radians, your denominator is just going to match. So if your denominator is 4, it's pi over 4. If your denominator is 6, it's pi over 6. Radians are actually easier once you get on board and get used to them. Perfect. All right, so let's switch over to our notes here. I have all these printed here for you. Off to the side, we're going to draw a little picture, okay? Now, I'm going to put my triangle in quadrant 1, just, for the sake of, I have to draw it somewhere, but there are 4 quadrants, so it could be any of them. This is your angle theta. That's a little Easter egg looking thing. Now, come with me on this. This is X, and this is Y. Do you see how I did that? Do you get why this one is X? It's the X-axis and then Y-axis. Also, you can think of it this way. This point is the point X comma Y. I don't usually like thinking of it that way. I like thinking of this side of the triangle as X and this side is Y, but if that helps you, that's true too. Now we call this R. The reason why is this, and watch, because I'll just take my paper clip and show you. If I start here and rotate the whole way around, I created a circle. Do you get that? And that R would be the what of the circle. It's the radius of the circle. Cool. That was not like pulling teeth. You all came with me on that. Now let's go over here and write our trig functions. Sine is opposite over hypotenuse. For this triangle, that would be y over r. You said it before I could even, which is good. No, you're fine. That's what I wanted. Do you see how it's y over r? Is everybody with me there? Y over r. How do we say this one? Cosecant would be r over y. They are just reciprocals, right? Cosine is adjacent over hypotenuse. So looking at this triangle, that'd be x over r. This is secant, so r over x. You get how it's not new information though? It's still SOHCAHTOA, calling it something different. Tangent is opposite over adjacent, so that's y over x. Cotangent is x over y. Now we're going to talk about the signs. So in quadrant 1, x is positive and y is positive. Everything is positive. So I'm going to just make another little coordinate plane right below here. We're going to write where they're positive. They are all positive in quadrant 1. Sine, cosine, tangent, cosecant, secant, cotangent. All 6 of them are positive in quadrant 1. Are we all clear there? Oh, and r, by definition, is always positive. Just by definition, the radius of the circle is positive, okay? But x and y can change. If you're in quadrant 2, your x is negative and your y is positive because you went to the left and then up. Are you getting what I'm saying there? Like if you plot a point over here, it's going to be negative, comma, positive. So which ones would be positive in quadrant 2? Well, any of them that involve the y value and r, because r is always positive. So which ones over here involve the y value and r? Sine and cosecant. Those ones are positive. Again, we're writing where they're positive. Sine and cosecant are positive in quadrant 2. Because just in a minute, we're going to play the name that quadrant game, and you have to figure out which quadrant you're in. Right? In quadrant 3, both x and y are negative. You went left and then down. So the ones that are positive are the ones that involve both x and y, because if they're both negative, then they will cancel out. So which ones over here involve an x and a y? Tangent and cotangent, because they cancel. So tangent and cotangent are positive in quadrant 3. Again, we're writing where they're positive. And then in quadrant 4, it's going to be what, comma, what? X is positive, good, y is negative. So if we're looking for the positive ones, it's going to be the ones that involve x and r, which would be the last two. So cosine and secant. Now, a way you can remember this is all students take calculus. All students take calculus. And then the reciprocal ones go together. All right, so we're going to name that quadrant. If you get stuck, there's only 4 options, okay? Pick one. You can usually figure out if it's not quadrant 1. So usually try and figure out if something's negative. Do you see how this says that sine is negative? Less than 0 means negative. Okay, that means it's not quadrant 1. And it's also not quadrant 2. If sine is negative, it can't be this one because they're all positive, and it can't be this one because sine is positive there. Do you see what I'm saying? Okay, so this piece of information narrows us down to it either being 3 or 4. It can't be 1 or 2 if sine is negative. This piece of information is going to help us pick which one of those. It says cosine is what? Positive. So out of these two, cosine is positive in the 4th quadrant. So 4 is your answer. Usually you're given one that's positive and one that's negative. So one piece of information helps you narrow it down. And then the second piece of information helps you pick which one it is. Okay. So look at this one. I would start here. This says that secant is what? Which means negative. Secant is negative. So it can't be quadrant 1. Good. And it can't be quadrant 4 if secant is negative. So that narrows us down to 2 or 3. And the other piece of information helps you pick which one of those. This says cotangent is what? Positive. So out of 2 or 3, cotangent is positive in 3. So 3 is your answer. So again, one piece of information helps you narrow it down. The other piece of information helps you pick which one of those. So looking over here, this says tangent. I usually start with the negative one. Tangent is negative. That means it has to be what or what? What does that narrow you down to? Good. 2 or 4. Because they're all positive in quadrant 1 and tangent is positive in quadrant 3. So it's either 2 or 4. This says cosecant is positive. So it has to be 2. Good job. Okay, so your first job is to figure out which quadrant your triangle is in, and then we're going to find all 6 trig functions. I didn't print them for you on purpose. It's not because I'm horribly mean. It's because the more you write them, the better you will remember them. So go ahead and write them. You're going to have to write them 3 times today. You are allowed to complain about that, but these are first world problems. And again, the reason I do it is you will remember them better the more you write them. It's not that much. You'll be okay. Then we're going to decide what quadrant we're in. So we're going to play the name that quadrant game. This says tangent is negative. You see that there? I'm not worried about the 4 over square root of blah, blah, blah right now. Just the tangent is negative. So it has to be 2 or 4. Good job. And then it says sine is positive. So it needs to be 2. So you're going to draw your triangle in quadrant 2. The right angle should always touch the horizon. The right angle should always be on that x-axis. Otherwise, you've drawn it sideways. All right, now we're going to go in and fill this in. Tangent is opposite over adjacent. I'm not going to worry about the negative just yet. If no one ever sat you down and explained negative fractions to you, that negative could go with the 4 or the square root of 33. Do you get what I'm saying? It's just sitting out front. So I'm going to ignore it for a second. Tangent is opposite over adjacent. So do you see how I placed those? Now, which one do you think gets the negative? Why does the square root of 33 get the negative? You went left and then up. So the 4 should be positive. How will we get R? This is our R value. Good. It hasn't been that long. You just took a test on it. Pythagorean theorem. So 4 squared plus, that squared equals R squared. You're going to be okay. Just work it out. It's easy. It's not hard. You just have to write it. So this will be 16. Now, when you square something negative, it turns positive. So it's going to be plus. And then what happens to the squared and the square root? They cancel, so it's just 33. When you square something negative, it turns positive. Negatives cancel out. So what is that? Oh my gosh, it came out to 49. So that means R is 7. Yeah, and R is always positive. No matter what, R is always positive. And then you just use that to answer the questions. Sine is opposite over hypotenuse. That would be what over what? Yeah, 4 over 7. So cosecant 7 over 4. Boom. Cosine is adjacent over hypotenuse. So that's your negative square root of 33 over 7. Secant, you're going to flip it. Yes, but I always save that for the end. Tangent, you can either look at your triangle or that was given in the problem. So like we were given that one. And then for cotangent, you're just going to flip it. Now there will always be two that you have to rationalize. So which two for this one do we have to get? Secant and tangent. So this will be negative 7 square root of 33 over 33, which looks worse, honestly. And then tangent will be negative 4 square root of 33 over 33. My square root symbol got weird. Let me fix that. That's essentially it. Let's try it again. That's the lesson. Now we practice. That's how math works. All right. Now this one's given to you in a slightly different way. You have the point, the coordinate point, negative 2 comma negative 5. Which quadrant are you in if they're both negative? The third, quadrant 3. The right angle should be touching the horizon. Negative 2 is x. Negative 5 is y. So go ahead and do your Pythagorean theorem to get your r value. Writes at a different pace, but if you figure that out, go ahead and list out your 6 trig functions. Again, I'm doing that to you on purpose because the more you write them, the better you'll remember them. I'm getting square root of 29. Is that doesn't split? 29 is prime. So you're just going to leave it square root of 29 and move on with life. Oh, also, I always have to remember to say this at some point. If I haven't said this before, if I'm repeating myself, I'm sorry. I do not know why I capitalize my trig functions. That is 100% a Miss Cole thing. I don't know why I did. Maybe I had a professor that did that once and I like just copied it. It's not like wrong, but they're not usually capitalized. You do that too. You probably do it because of me, so I'm sorry. I like it too because it reminds me it's an abbreviation and not a word. I probably just had a teacher that did it once and so I. Oh yeah, thank you. I can't have tangent on there twice. What I get for talking and writing at the same time. Thank you. It'll look out for each other. All right, so sine is opposite over hypotenuse. Using your triangle, and this is where your little theta goes. Your theta goes by the origin. That would be what over what? Negative 5 is opposite over square root of 29. And then you're just going to flip that for cosecant. Cosine is adjacent over hypotenuse. So negative 2 over square root of 29. And then for secant, you're just going to reciprocate it. Tangent is opposite over adjacent. Now that's negative 5 over negative 2. And your negatives cancel. That's why tangent is positive in the third quadrant. It's because they're both negative and then the negatives cancel out. And then cotangent is 2 over 5. I always save this for last. Now there will be 2 that you have to rationalize. So which 2 is it? It's sine and cosine. Good. So this will be negative 5 square root of 29 over 29. And then I'm not going to say this one out loud. It's annoying to say the same thing over and over again, but there you go. You okay? Everybody's like struggling today. You okay? You're good. You got this. There's only one more we're going to list out all of these for. The last one, I'm just going to have you draw the picture. So we'll go ahead and list these out one more time. You will remember them better the more you write them. While we're writing those, I'm going to tell you, on Delta Math, when you go to do your practice, instead of all 6, they only ask you for one of them. I will tell you from experience, though, that does kind of mess people up because they're like, you get used to doing the whole everything. And then when you just have to do one, it kind of messes people up. So what I always tell everyone is there's nothing wrong with writing out all 6 and then just picking the one that you want to type in. It doesn't actually take all that long. So if you're one of those people where you're like, I can't just do one at a time, like I need to do the whole thing, then just do that. It doesn't take that long. All right, now this one, instead of a coordinate point like this one was, you're given an equation. All that means is there's one extra step where we're going to come up with the point on our own. Now, you can plug anything your heart desires in for X, except it has to be what? Yeah. Positive. Oh, why? Thank you. Would 3 be a smart number to plug in? It's positive and it cancels that out. So you can pick anything you want, but be smart about it. 3 is a good choice. So if you plug 3 in, I'm just going to take you through this verbally. 1/3 times 3 would be 1. So you get 1 plus y equals 0. And so what's your y number? Good job. Perfect. I think that's the easiest that's ever gone. So what quadrant are we in? 4, good job. Your right angle needs to touch the x-axis. Theta is, by the origin. X is 3, y is -1. And then you'll do your Pythagorean theorem to get your r value. Again, when you square a negative, it's going to be positive. And so what is that going to come out to be for our hypotenuse? Square root of 10. So sine is what over what? Yeah, good. So that's -1 over square root of 10. If you flip that, it's square root of 10 over -1, which would actually just be negative square root of 10. I wouldn't mark this wrong, though. That's fine. Cosine is adjacent over hypotenuse, so 3 over square root of 10. Wait, what?
It's a really loud buzzing.
Oh, sorry, I'll turn it off in a second. It's that.
Not,
Oh, you don't?
I've never heard it before.
I think it's that. I'll turn it off in a second. We're almost done. All right, tangent. What was that? Tangent is what over what? Or 3. Good. Opposite over adjacent. And if you flip that, it would just be -3. If you write -3 over 1, that's fine though. So which 2 are we going to have to go back and rationalize? Yeah, cosine and sine. So this would be -1 square root of 10 over 10. The reason why I wait and do that at the end is if you rationalize first and then go and try to flip this, it becomes more difficult. So just save it for the end. Okay. Oh, question. Go ahead. Yes, that is a typo. This should be TAN, obviously. Well, you were ahead of me. I didn't even get to that yet because I was gonna say that. Okay. Okay. Just stay with me instead of ahead of me. So all we're gonna do for this one is draw the triangle. I'm not gonna make you list out all the things. So we're gonna play the name that quadrant game. Sine is negative. So which 2 does that narrow you down to? Sine is negative. 3 and 4. So it's 3 or 4. Tangent is positive, so 3. So you're going to draw your triangle in quadrant 3. Again, the right angle touches the x-axis. This is your theta right here. No, has to touch the x-axis. Otherwise, it's sideways. Now, don't worry about this negative. We'll deal with that in a second because I don't know if it goes with the 3 or the 5. Sine is opposite over hypotenuse. So which one of those gets the negative? By definition, your R value is always positive. So it can't be that one. Now you should be able to get this without doing the Pythagorean theorem because it's a 3 blank 5 triangle. But it's actually, why is it negative 4? Because you went to the left. Real quick, let's review all of our locker combinations. They help you if you know them. You don't have to do any work. 3, 4, 5. Does anyone know another one? 5, 12, 13 is another one. 7, 24, 25. 8, 15, 17. There's obviously infinite more because numbers go on forever, but those are the 4 that I know.